Hey Math 30-1 students, we're looking at 7.3 solving exponential equations. So recap from yesterday is, what if they asked for the y-intercept of a function? Which one would it be? What's hard about this one is they're not giving you any numbers to actually try it out and find what it is. So we can still use our algebraic approach. Whenever you're trying to find the y-intercept, you set x equal to 0. So I'm going to write y equals, instead of f of x, a to the power of 0 plus 1. And I still have this plus b. Y equals, well, 0 plus 1 is equal to 1. And so y is equal to a to the power of 1 is a plus b. So if we ever add together our k value, which in this case is our b, and our constant, or our base actually, so the base plus our k value in any case, they should add to the y-intercept. So that's a little trick that you can use to find the y-intercept value. Exponential equations can be written in different forms, so it's often useful to rewrite an exponential expression using a different base than the one that's given. So if that's possible, we call this common base method or same base method. So for example, 4 and 8, if you look at the two bases, they can both be written as 2 to the power of something. So we're trying to get them both to have the same base. So in our case, we would use 2 to the power of 2. The reason being is 2 to the power of 2 replaces 4. And so since this is 4, you still need to write that 2x outside of the bracket because that does not go away. These two guys need to be included. Okay, so I have 4 still to the power of 2x. And then instead of 8, I'm going to write 2 to the power of 3 because that replaces 8. And then x plus 1 would go outside of that bracket. Now this is where we have to practice our exponent laws. Our exponent law says that whenever I have a base with a power raised to a new power, you always multiply your powers together. So that's what we're going to do here. We're going to write 2 to the power of 2 times 2x is 4x now instead, because we're multiplying the two exponents together. And 2, the base, we're going to multiply these two guys together, but we need to distribute. So that's what's important in this step, is to multiply that 3 to x plus 1 properly by distribution. So that's a common error that people forget. What is cool about this method is if the two bases are equal to each other and there's only one on each side, so I have 2 to the 4x equals 2 to the 3x plus 3, these bases will cross each other off, because if they're equal, then the powers are equal to each other, which means we can eliminate that base and just work with the powers. And so all we have to do is isolate for x. Move this 3x to the other side, and it becomes x is equal to positive 3. You can always check by placing that back into your original question and seeing if left side equals right side, but this is the answer. So this method for solving an exponential equation is based on the property that if you have two bases, for example, c and c are equal, then you can make x equal to y. So the only issue is that c cannot, meaning your base can't be equal to -1, 0, and 1. So as long as that's true, then this property will be true as well. So let's practice that. We're going to try to rewrite these as the base of 2. So instead of 4, we're going to write 2 to the power of 2. Don't forget, if there is already an exponent, don't leave it out. And then we would multiply these guys together, and it becomes 2 to the power of 6. Our next example, we want to rewrite the bottom and the top. So anytime you have a 1, that's the same as saying 2 to the power of 0. And then 8 is the same as saying 2 to the power of 3. Now, whenever we divide am over an, we actually subtract them. So this is what it's going to look like. You're going to have to go 2 to the power of 0, subtract 3 for this to actually work. So that means it's going to be 2 to the negative 3. So that's our answer. 8, we're going to rewrite it as 2 to the power of 3 with this 2 over 3 outside of that bracket. And then underneath the square root, we're going to write 2 to the power of 4, which is still 16. And then outside of that, we still have to the power of 3. So whenever we multiply the 3 and the 2 over 3, I'm going to rewrite it as 3 over 1 multiplied by 2 over 3. Okay, so that's going to become 6 over 3, which simplifies to 2 to the power of 2. Our next part, we're going to multiply by, whenever you have a base and an exponent, so here you have a power, and in front, even if you don't see it, there's an index. Whenever you write a number, if you ever see this, the top is going to be your power divided by your index. So this is how you can write it as a base with a power. So you write power at the top, index at the bottom. So in our case, we're going to have our power is 4, our index is 2. So anytime you don't see an index, it's 2. And then we still have this power of 3 outside of the function that we still need to include. And then 2 to the power of 4 over 2 is the same as 2 to the power of 2. Still that 3 outside there that we're going to have to multiply. And then 2 to the power of 6, because 2 times 3 is 6. Lastly, whenever you have two bases that are multiplying that are the same, that's the rule of am times an becomes am plus n. You're going to add the powers together. So that's going to be 2 to the power of 2 plus 6, which is 8. So that's your final answer. Okay, so being able to use your exponent laws helps a lot in this unit. So make sure you practice and look over your exponent laws. Example number 2, solve, check your answer using graphing technology. Again, we're going to use that common base method. So 2 to the power of 2, 2 is already the base that we need, so that stays the same, but the 4 will be 2 to the power of 2. X plus 3 goes outside of the bracket, then you're going to distribute that 2 to all the numbers afterwards. So the left side stays the same, but on the right side you're going to have 2 to the power of 2x plus 6. Whenever the bases are the same, you can cross them off and make your powers equal to each other. Bring that 2 to the other side by subtracting 2x. So 4x minus 2x is 2x equals 6, and then you divide both sides by 2, which means that x equals 3. Now in this case, I want them to be 3 to the power of something. So 9 would not work with 2's here, so I'm going to work with 3 now. So you're just picking a number that both of them could be replaced with. So as long as you can say 3 to the power of something gives me 9, and 3 to the power of something gives me 27, that's how I pick the base. So 3 to the power of 2 replaces 9 with the 4x still outside. 3 to the power of 3 replaces 27 with the x minus 1 still outside. And then we are going to multiply the powers together. 3 to the power of 8x equals 3 to the power of distribute 3x minus 3. Now the bases are the same. They cross each other off, leaving you with 8x equals 3x minus 3. Subtract 3x on both sides, which gives me 5x equals negative 3, and then divide both sides by 5. So I'm going to leave my answer as a fraction. So I'm going to say x is equal to negative 3 over 5. Done. solve, check your answer using graphing technology. So with this previous one, I know that all these answers are correct, but to check, you would just go back to the original. You would put y1, y2, you'd go to your graphing calculator, and you'd find the intersection between them. And as you can see, in this case, it should be 3 for the first one, and then same thing for the next one. You would go y1, y2, find the intersection, and the intersection should match the point of negative 0.6, because that's what that is as a decimal. Okay, so that is how you